Okay guys, today we're going to go over function overloading and function recursion. We'll start with function overloading. Basically how this works, here I'll show you this first. Let's just say you want to be able to add integers and doubles in your program. So what's happening here is this function right here is going to have an integer of x and an integer of y, and it wants to return x plus y. Now when we run the function, when we call upon this plus function integer, the numbers that we're going to put in here are 8 and 5. So when you add 8 plus 5, you get 13. And then here's your cout down here. What's in the quotation marks is right here. And then my number 1 comes from right here. And that equals the plus function integer of 8 plus 5. And that happens right here. So for your double, it works the exact same way. Plus function double. You have an x and a y. Here's where they're here's where they're at. So double my number 2 right here. Double my number 2 equals plus function double equals this function if you put in the inputs of 4.3 and 6.26. So your return is going to be the sum of 4.3 and 6.26. And here's your cout. Double is in the quotation marks. That is right here. And then after double, we write whatever my number 2 came out to be. 10.56, 4.3 plus 6.26. Now, put your eye on the code right here. We are now going to do the function overload with very little change. But basically, function overloading isn't quite as the name implies. It's not, overload makes it sound like it's going to fail, but it's not going to fail. It simply means you can reuse the function, because notice here, the function names are identical, where over here, the functions are separate. They have different names. The way that you can reuse the same function is by changing the parameter. If you change the parameter, you can use the same function name, the same function. Let me see here. So when we go through this code, it is the same exact concept as it was over here. The plus function. Now here's what designates which one you're using. Are you using this one for integers or this one for doubles? So you're going to say integer, my number 1. We're going to use the plus function of 8, and we're going to use 8 and 5, which gives us 13 just like before. Now this time we're going to say we want a double. We want a double. And we're going to call this my number 2, and we're going to use the same plus function, but we want the version of that does doubles, which is right here. And you have your x and your y just like before, and they add up to 10.56. So hopefully that makes sense. I know it's kind of hard to see a point to this right now, like what's the difference whether you do that or that. It's the same amount of code. But you know, notice how you declare what you want the function to do with the parameters under your main function. And down the road, this is handy for condensing your code. This is what this is all about, making it so you have to code less. Okay, so actually, let me add one more thing to that. Do you remember what we talked about in the previous lecture about how you can have all your functions listed up here, but all of the parameters of what they do, the dimensions, can all be down below, and that way at the very top of your code you can see all the different functions you have available. So when you think of things in that regard, using the same function, because you can call it plus function, and you can say, okay, I want an integer, I want a double, I want, you know, I can probably work with Boolean as long as you're only using zeros and ones, but that's the concept behind this. Okay, now let's go over to the hard one, recursion. Okay, so this is saying, okay, how do I run through this? Okay, if k is greater than 0, we want to return k plus the sum. No, wait, I'm sorry, I need to change this right now. Let's just call this function. Because if you are a student in math, that's going to throw you off by calling that sum, because it looks like it wants the sum of this. But what you're actually doing is you're returning k plus the function of k minus 1. Have to change it right here too. So when you run your main, this is going to start as a 10. So this 10, we have the integer of 10. 10 is greater than 0. So we're going to return k plus 10 minus 1. Now this is a 9, which is still greater than 0. So now we're going to return k plus 9 minus 1. Now this is an 8. 8 is greater than 0, so we're going to return k plus 8 minus 1, which is 7. So essentially what you have is 10 minus 9 minus 8 minus 7. And then once it hits 0, the function stops. Now, your result is actually the sum of all of these numbers. This is what your function is doing, but each time it reduces, it is it's adding to your result. Let me see, where is that happening? Oh, I'm sorry. It's happening because it's calling upon the function itself. K increases every time this, it's not a loop, it's a function, but every time I don't know how else to put it, but the loop occurs. So k becomes k plus 8, or 8 minus 1. K becomes k plus 7 minus 1. And it just keeps adding them up. So 10 plus 9 plus 8 plus 7, so on and so forth. It does equal 55, and you can check that on your calculator if you want. Let's just say I turn this into an 11. Now what's the result going to be? Basically all you're doing is putting an 11 right here, right? So 55 plus 11 is going to be 66. Oh man. Oh, silly me. There we go. And there it is. So that's how recursion works. I know it's a little bit confusing. You might want to play with it and see what you can figure out.